Assalamu alaikum. Today I talk about container orchestration with Kubernetes. In this presentation, I will discuss about the Kubernetes core components, Kubernetes objects, Kubernetes services, Kubernetes volumes and storage, and last of all, Kubernetes networking. Kubernetes core components. Here the key building blocks are API server. The API server acts as the central management point for cluster communication and external requests. etc provides a distributed key value storage essential for storing cluster data with a strong consistency. Controller manager. The controller manager oversees controllers that maintain the desired state of cluster objects for operational efficiency. And then core components, scheduler, Kubelet, Kube-Proxy. Kubernetes scheduler. The scheduler assigns pods to nodes based on available resources and define policies for optimal performance. Kubelet agent. Kubelet ensures containers are running as expected, managing their lifecycle on a specific Kubernetes node effectively. And Kube-Proxy network. Kube-Proxy manages network rules on nodes, facilitating seamless communications between different services and pods in the cluster. Control plane architecture. Key components of Kubernetes control plane. Here is the concept is the slide focuses on understanding service routing and communications, likely explaining how external traffic reaches the correct internal applications. And the diagram center this symmetric maps the logical flow of data showing traffic entering the Kubernetes cluster and being distributed down to specific services or workloads. The illustrated right side, this is a conceptual 3D visualization showing the Kubernetes architecture featuring icons for pods, nodes, and the control plane connected in a network. It is an educational slide meant to visualize how Kubernetes manages traffic flow between the internet and applications. Kubernetes objects. Here the understanding core components are Kubernetes pods. A Kubernetes pod is the smallest deployable unit containing one or more containers that share resources. Kubernetes deployment. Deployments manages the rollout of multiple pods, ensuring desired states, facilitating updates without downtime. Kubernetes replica set. A replica set ensures that a specified number of replicas are running at any given time for reliability. Kubernetes objects key resource management. Namespace overview. A namespace logically partitions cluster resources, allowing for effective management of multiple environments and teams. ConfigMap, config, ConfigMap functionality. ConfigMaps stores configurations data accessible by ports, enabling dynamic configurations and environment separations for applications. Secret management. Securely store sensitive information like passwords and tokens, ensuring data protections and restricted access in Kubernetes environments. And then Ingress and StatefulSet, managing external access and states. Ingress manages external HTTPS access to services, while StatefulSets facilitate deployment of stateful applications, ensuring stable network identities and persistent storage for each instance. The Kubernetes object relationships, understanding how objects interact and connect. Here the diagrams score. This slide focused on the understanding service routing and communications, likely explaining how external traffic users reaches the correct internal applications. And the center diagram, this symmetric maps the logical flow of data showing traffic entering the Kubernetes cluster top clouds and being distributed down to specific services or workloads, the boxes below. And the illustrations right. This is a conceptual 3D visualization showing the Kubernetes architecture, featuring icons of pods, nodes, and the control plane connected in a network. The Kubernetes Services. Exposing applications in Kubernetes. Kubernetes services such as ClusterIP and NodePort facilitate applications. Exposure ClusterIP enables internal port communications, while NodePort allows external access via node IPs on specified ports. Kubernetes service traffic. There is understanding the service routing and the communication system. Kubernetes volume mechanism overview. Understanding volume mechanism, Kubernetes volumes provide essential storage solutions for containers, allowing for persistent and ephemeral data management. Understanding each type is crucial for effective application deployment and data management strategies. Persistent volume concepts. Understanding persistence volumes and persistence volume claims is crucial for managing storage in Kubernetes clusters effectively. Persistent volumes represent actual storage resources, while persistent volume claims request and build these resources for pod uses, ensuring data persistence across pod life cycles. Kubernetes storage flow. Understanding storage in Kubernetes architecture. It provides a visual guide for understanding storage in Kubernetes architecture, showing how temporary and permanent data coexist. Exist. In the Kubernetes volume, the top right section displays different volume types such as EmptyDir, temporary HostPath, and persistent volumes, which dictate how a container accesses a file system. And the persistent storage overflow, the central and lower diagrams illustrated the relationships between persistence volumes and persistence volume claims, showing how applications request and successfully bind the physical storage resources. And then Kubernetes networking, CNI and port communications. The container network interface enables seamless communications between ports in Kubernetes, facilitating a flat network structure that allows direct connectivity without the need for network address translation. And then Kubernetes networking, understanding layers of Kubernetes networking. The big picture, it covers understanding layers of Kubernetes networking, especially how data moves between ports, services, and the outside world. And the networking layers, left side, the diagram visualizes the hierarchy showing how services, IPs route traffic to individual ports and how different components within those ports interact. And the container network interface, right side, this section highlights the CNI, which is the standard that allow Kubernetes to use different networking plugins like Plant to manage connectivity. And the last one is next steps, mastering Kubernetes for effective management. Understanding Kubernetes architecture is crucial for successful cluster management. Explore hands-on practice and advanced security topic to enhance your skills in cloud native environments. Thank you all.